Hello. This is just some quick review material from FDLS115 for the course Math 120. And we're just going to quickly take a look at some of the things that you should have learned in FDLS 115. So a quick overview of the topics on this video: attitude and practice. Some aspects about learning algebra, having a good attitude, and practice, practice, practice. Quantities in algebra, operations with integers and terms, basic properties of algebra, evaluating expressions, solving equations, and then ratios, proportions, and percents. Now, many students have math anxiety. It's only by facing and understanding the anxiety and then working through that anxiety to have success in math that a cure is probable. So we got to understand the causes first. Here's an acrostic that I made up after reading a couple books on math anxiety. Some people have anxieties about math because of, in the past, there was an authority figure, the teacher, that you feared. Maybe the teacher humiliated you, made you nervous. Maybe it was an over reliance on the teacher giving the answer. So it's all about authority. Negativity, maybe family members or the teacher that has caused you a lot of negativity, negative comments or body language. Exactness, there's a exactness in math and you have a fear of this wrong answer or not doing it right, or a feeling that you have to logically get everything exactly right. Incomplete learning. In the past, there might have been gaps in your learning where a teacher didn't fill in all the gaps and then left it for the next teacher, and then that teacher didn't fill in gaps. And so you have misunderstandings here and there that are preventing you from understanding further topics. Evaluation, you have a fear of public speaking or writing on the board. Maybe the fear of being evaluated. I mean, this might be true of a lot of subjects, but for math as well. Time pressure, maybe time tests or stress is causing that. Not having enough time to think it through. And then your attitude. There's internal mind games you play where you talk to yourself about, I can't do this, or you don't have a positive attitude. So those are some things, and so think about those, see if they apply to you, and um, you know. So one way to reduce anxiety in math is to combat that lost feeling, the feeling that you are just manipulating symbols without understanding what they mean. By all means, in mathematics, you always want to seek to make sense of it. Make sense of what the symbols are and what the problem is saying. Now, some terminologies about quantities in algebra. What is a term in algebra? A term is a number or the product of a number and one or more variables. Now, we call unknown things variables, like we use X or Y to stand for an unknown quantity. So if you have either a number or the product of a number and a variable, or multiple variables multiplied together, that's called a term. But the key thing is that the operation has to be multiplication in a term, in a single term. So here's some examples. -5, 3 times a, negative x times y, 8x to the third power, which really means 8 times x times x times x, and then just z. Now z is the same as 1 times z, so it's a number times a variable. What is an expression? An expression is either one term or several terms separated by plus or minus signs. Now 7a is a single term, so we call that a monomial. Binomial could be something like 6x plus y, where you have two terms separated by a plus sign or a minus sign. Here's another two-term expression, a binomial, 4x squared minus 9x. Here's a trinomial, b squared minus b plus 6. Because the terms are separated by plus or minus signs, that makes this a three-term polynomial or a trinomial. Items with no plus or minus sign in between them are multiplied. So this means 4 times x times y. This means 2 times the parentheses x plus y. Now in the parentheses you have a plus sign, but between the 2 and the parentheses, that's a multiplication operation. And then -1 parentheses times -5 in parentheses, that would be multiplication. All right. Now the degree of terms. A number like 7 is called a constant. 3 or -2, they're all constants. Degree 0. A term with just one variable, one unknown, is like 7x. That's called a linear term. Linear for degree 1. Okay? A term with two unknowns, like 7x squared or 7xy, is called a quadratic term. When you have two unknowns multiplied together, that's a quadratic term. A term with three unknowns, like 7x to the third, that means 7 times x times x times x. So because you have three x's, three unknowns multiplied together, it's a cubic term. All right? And you can go on and have degree 4, degree 5, whatever, as long as you have that many unknown things, variables, multiplied together. Now, we always want to have meaning in math. So let's think about what variable expressions could mean. So suppose you have this here where this is x. It's not drawing. So you have right here, you've got that length is x. Right? So if x is that length, then what would be 1/2 x? Well, you'd make a bar half as long as x. So that would be the representation of half x. 1.5x would be a bar 1.5 times as long as x. Okay, so 50% more, 1.5 times x. If you have x and you add x, well, that's like taking two bars that are each x long, like this and this, then you would have a total of 2x, or x plus x. Now, x squared, well, that's a whole different thing. It's no longer a linear term in a line. It would be something like this here, which represents the area of a square that has dimensions x and x. So x squared is a quadratic term, and it would be representative, or could be representing the area of a square that's x by x. Now, if you add half x to the dimensions of this square, and now you have a side that is 1/2 x long, or excuse me, 1.5x long, and again the height of this is still x, as on the other side over here, as you see. So the area now of the whole rectangle is 1.5x times x, or 1.5x squared. So it's 50% larger because you extended one dimension by 50%, but it's 1.5x squared. Now, if you wanted to express x plus 2 inches, like you've had x plus 2, that would be represented here by this diagram here, where this represents x plus 2 units, okay? But if you had a bar that's 1 inch less than x, then you'd write x minus 1. All right? Operations with integers. This should be something that you can clearly understand from your experience with cash and debt. So if you had 7 plus -4, well, -4 could be thought of as $4 of debt. So you take $4 of your cash and you pay off that debt, so you now have $3 cash. So 7 plus -4 is 3. -8 plus -3, that could be thought of as debt plus debt. So debt plus debt is more debt, -11. Debt and cash, -8 plus 5. You could think of it as taking 5, -5 off from the -8. In other words, splitting -8 into -3 and -5. And then grouping together the -5 and the +5. Of course, that would cancel right out, and so you get -3. So take the cash and pay off $5 of the debt, and you still have $3 of the debt. So if you have more debt to begin with than cash, of course, that would still be in debt. All right, so then when you have terms that have variables, you have 5a, for example, plus -9a. Well, 5 and -9 is -4, so it'd be -4a. Now notice you don't change what you have. You have 5a's and -9a's make -4a's, not a squareds or something else. It's just apples and apples makes more apples, or less apples if you're subtracting. And then x squared plus x squared would be 2x squared. And that could be represented by this picture here, because this first square has an area of x squared, and the second one also has an area of x squared. And you add x squared plus x squared, and you get 2x squared. Now you can also do that thinking about it as a long rectangle. So the dimensions of this is 2x long and x high. So 2x times x gives you 2x squared. So either way you look at it. But you add like terms by adding the coefficients. So like this was 1x squared added with 1x squared, so it became 2x squared. So if you have 5x squared and 3x squared, that would be 8x squared. Now with subtraction, you can think of subtracting 8 as adding -8. 5 minus 8 is the same as 5 plus -8. And then that would give you -3. -9 minus 4, well, that's the same as -9 plus -4. And a debt plus a debt makes more debt. And then here, when you have 7 minus -2, well, you can think of that as adding the opposite. But what's the opposite of -2? It's positive 2. So it's 7 plus 2, which is 9. So in other words, you can change a minus, a negative, into just plus the positive. You're using this rule right here. Here's another example. 5b minus 8b, that'd be -3b. Because you can think of it as adding -8b. Here you have a double negative, subtracting a negative, same as just plus the positive, and you get 0.6x. Here, same thing, double negative, same as plus positive 6y squared, and you get -3y squared. Now, let's think about multiplication. You know that a positive number times a positive number is positive. So you live in Alaska, and let's say you get 2 inches of snow every day for 5 days. Well, 2 times 5 is 10, an increase of 10 inches of snow. But suppose you could go back in time. Let's just pretend we can go back in time. And so we're going back 5 days before you got the snow. Well, 2 times -5 would be -10. In other words, you have 10 inches less of snow than you have now. And so going back in time, before the snow fell, of course you're going to have 10 inches less than you have now. Or what if the snow is melting by 2 inches per day? So now we're talking about a decrease in the snow. So -2 times 5 would be -10. So it's 10 inches less of snow than you have now. But now let's do both of those. Let's go back in time before it melted at a rate of 2 inches per day. So melting is a -2. Going back in time is like a -5. So -2 times -5, that would be +10 because you would have 10 inches more snow than you have now because you're going back in time before the snow melted. All right, so think about that. That helps explain why a negative times a negative should be a positive. Anyway, the rules are given here, listed here. If you have just one negative, it's going to be negative. Oops, that right there should be a negative sign. So this is wrong. This should be a negative sign right there. And then a negative times a positive would be a negative, and then a negative times a negative is a positive, right? And then here's the general rule. If you have an even number of negative signs, it's going to be positive. If you have an odd number of negative signs, then it's going to be negative. All right. So let's say you had 5 negative numbers multiplied together. Well, the result is going to be negative because it's an odd number. 5 is an odd number. The rules for division are the same as for multiplication. Some basic properties of algebra. If you have 0 and you divide it by a number, any number, it's going to be still 0. But if you try to divide a number by 0, you can't. It's undefined. You try it on the calculator, take any number and divide it by 0, you're going to get error. All right. Then if you have a number and you add the opposite of the number, well, then you get 0. 5 and -5 adds up to 0. All right. What if you have a number times its reciprocal, a times 1 over a? Well, the a's are going to cancel, and you're going to end up with 1. And that's, you're going to end up with 1 over 1, or a over a. If you don't cancel, just multiply the tops together, bottoms together. But a over a would equal 1. So any number times its reciprocal will equal 1. The absolute value of -a is the same as absolute value of positive a, which would be a if a is positive. Okay, so in other words, an absolute value will always give you a positive. The commutative property says the order in an addition problem doesn't matter. So I can add a plus b, and I'll get the same result as adding b plus a. And this works also for multiplication. A times b is the same as b times a. Associative property says if you have 3 things, it doesn't matter what order you add the things together. So I can add the first 2 things, a plus b, and then add the c, or I can add the b and the c and then add the a. It doesn't matter the order. Same thing with multiplication. It doesn't matter which order you multiply the things together. Distributive property says if you have something times the parentheses with a plus or minus sign in between, then you can distribute the thing on the outside that you're multiplying to both of the terms inside. So it'd be AB plus AC. So here's an example that uses all 3 of those last properties that we just mentioned. So if you have this expression, 2x plus 7 plus 3x, first thing you could do is rearrange the order of the things. I'm going to move this whole parentheses, 2x plus 7, and switch it and put it at the end of the expression. So I'll start with 3x and then have 2x plus 7. Then I'm going to use the associative property and switch the parentheses around and group together. Notice how I'm grouping together 3x and 2x. So that can be combined, right? Then I notice that I have an x in each of these two terms inside the parentheses, the 3x and the 2x. I have an x inside, so I'm going to distribute out an x, leaving 3 plus 2. But 3 plus 2 is just 5. So I have x times 5 and then plus 7. Now, of course, x times 5, I could use the commutative property for multiplication and switch it around and say 5x plus 7. Now, that's, something you probably could have looked at the original expression and said, oh, I could add the 2x and the 3x and get 5x and then plus 7, and you automatically put your x term first and then your number. But why can you do all that? Why can you manipulate that and move all that and do what you did? Well, these are the properties that enable you to do that. Okay, so more examples of the distributive property. Some students have trouble with fractions, multiplying things with fractions. So if you have negative 3 over 2 multiplied by 4x plus 6, you can distribute the negative 3 over 2 to each thing in that parenthesis. So I'm going to distribute it to the 4x, and then I'm going to also distribute it to the 6. So I'm going to go negative 3 over 2 times 4 over 1x plus negative 3 over 2 times 6 over 1. So notice I'm making the whole numbers over 1. So then you can multiply the top numbers together and the bottom numbers together. So you get negative 12 over 2. Well, negative 12 over 2 becomes negative 6. So you have negative 6x. And then on the second product, negative 3 times 6 is negative 18. Negative 18 divided by 2 is negative 9. So you have negative 6x minus 9. All right, next example, you have 2 times this parentheses minus this parentheses. Now, one thing you can do is treat this minus sign here as like if it was a negative 1, and then basically we'll distribute that negative 1 to both of the things in the second parentheses. Now, I treated the minus 5 as plus the negative 5, and I changed minus 4 to plus negative 4. But either way, you're going to distribute the 2, so you get 6x. 2 times negative 5 is negative 10, so 6x minus 10. And then negative 1 times x would be negative 1x, or negative x. And then negative 1 times negative 4 is positive 4. So then you can add your like terms. 6x and negative x is 5x. Negative 10 and 4 is negative 6. So you can either write it like this, or if you want, just write 5x minus 6. But you definitely want to distribute the numbers in front or the negative sign to both things inside the parentheses. All right, so now let's look at some properties that are used to solve equations. So the first property is called the addition property. It says if A is equal to B, then I can add C to both sides. Notice I added the same thing to both sides. So that's what you'd use if you had x minus 5 is 7. You could add 5 to both sides. So negative 5 added with 5 would give us 0. So that would basically cancel out the minus 5. And 7 plus 5 is 12. So x is 12. If you have an equation where things are moved around, always focus on the side that has the variable. So here's your variable, and what's there? Well, I've got a negative 3. So the opposite of negative 3 is a positive 3. So add positive 3 to both sides, and so negative 7 equals x. So, subtraction property. So this says that you can subtract the same thing from both sides of an equation. So I have x plus 4 equals negative 3. Well, I can subtract 4 from both sides, and that basically cancels that, and you have just x equals negative 7. Same thing here. I'm going to focus on the side that has x. I've got a 7 to get rid of. So I subtract 7 from both sides, and that gets rid of the minus or the 7 that's on the side with the x. So you have x equals -2. All right, multiplication property. It says you can multiply both sides of an equation by the same thing. And so if I have 1/3 x equals 10, well, if I multiply by the reciprocal, I multiply by 3/1 on both sides. That will get rid of the fraction, 1/3. So if I multiply by 3, the 3's just cancel out. So you'll have just x equals, well, 3 times 10, which is 30. On this problem, I've got a fraction of -3/7. I want to multiply both sides by the reciprocal of that. So I flip it over, and I get -7/3. Now, the negative sign, where that is, doesn't matter as long as you still have it. But just flip it over, be 7/3, but put a negative sign on it. So the reason for that is so that everything comes out positive on the side with the x. So you get positive 21/21, which cancels and leaves you with just 1x or just x. Now on the right side, on the left side, you have this, but I can cancel 3. 3 goes into 12 4 times. So then you get -7 times 4, which is -28. If you have a problem that you want to get rid of something that's multiplied, like 5x equals 8, you can divide both sides by the same thing. So on this problem, I simply divided both sides by 5, and you get this cancels, so you have just x equals 8/5, which is 1.6. On this next example, I'm going to focus on the side that has x. It's multiplication there. So the opposite of multiplying by -7 is to divide by -7. So I divided both sides by -7. These -7's canceled. I probably shouldn't have the division bar here in the middle. But anyway, those cancel. So you get x is -2/7. Well, a negative divided by negative is a positive. So you end up with just 2/7. All right, so evaluating expressions means finding the value of the expression. The word value is inside that word evaluating. So I have an example. The amount of cardboard, the surface area S of a box that is 18 inches wide, 24 inches long, and 12 inches high is found by this formula. Thus, all right, we're just going to plug in our numbers. Substitute in the width, the length, and the height. So put them in their appropriate places for L, W, and H, and you get this. You want to do any multiplication first here. So 24 times 18, that's 432. 24 times 12 is 288. 18 times 12 is 216. And then you can distribute, actually you can add these together, add them all together, and you get 936. And then 2 times 936 is 1872. It's easier to add them together first and then multiply by 2 rather than multiplying by 2 3 times and then adding together. But whichever way would work. Here's another example. If you have the expression -3xy plus 2x squared, if x is -1 and y is 5, just substitute in those numbers. You get this expression here, and you want to do any exponents first. So -1 squared. -1 squared would be -1 times -1, which is +1. And then you can do the multiplication. So you multiply all this, you get 15. You multiply 2 times 1, you get 2. So your final answer is 17. So you're using the order of operations, parentheses, exponents, multiplication, division, then addition and subtraction. However, keep in mind that multiplication, division, they are done from left to right. Same with addition and subtraction, from left to right. So sometimes division might come first before multiplication, and subtraction might come first before addition. It depends on whichever's first as you go from left to right. So you can try these two expressions, plugging in the numbers. I'll give you the answers in a minute. If you pause the video, go ahead and work them out. I'll tell you what the answers are. Okay, the answer for the first one was 49. Okay, pause the video and try the second one. Okay, so on this second one, it's pretty tricky with the fractions, but you want to plug in x, so you'd have 6 times 1/3 squared, and then 3 times 1/3 minus 2 to the third power. Now, 1/3 squared is 1/3 times 1/3, which would be 1/9. 6 times 1/9 is 6 over 9. 6 over 9 is 2/3. So this expression here comes out to 2/3. Now, on the second parentheses, 3 times 1/3, that would equal 1. And 1 minus 2 is -1. So you have minus -1 to the third power. But -1 to the third power is -1. So you have minus -1. Now, minus -1 is the same as +1. So you basically have 2/3 plus 1, or 1 and 2/3. All right, so there are a few different types of equations. I classify them as one-step equations, where the variable is linear equations, where the variable is to the first power, and then there's a one-step or a two-step or multi-step. You're always going to be trying to undo what's being done to the variable. So in the first equation, you're going to get rid of the +7 and undo that. You're going to subtract 7 from both sides. In the next equation, you're going to get rid of the -4. Well, the way to get rid of that is to add 4. The next example, you've got multiplication. So opposite of multiplication is division. Next example, you've got division. So the opposite of division is multiplication. In the second type, two-step equations, there's two things you got to do to it. So first, work on the thing that's added or subtracted. Any term that's added or subtracted, get rid of that. Then get rid of what's multiplied or divided for the variable. All right, so you can solve these. I'll tell you what the answers are in a second if you pause the video. Okay, so I solved all these equations. The first one is x is 11. Second one is x equals 9. Third one, x equals 3. Then x equals 28. In the two-step equations, you have x equals 2, x equals 6, x equals 4, and x equals 16. So if you're struggling with this, I know probably the fraction ones can be a little bit tricky, but you might want to go back and review your FDLS115 notes on this, or see the tutor either online or at one of the centers. Okay. Then if you have problems that are multi-step equations, where there's a lot of steps to solving an equation, you want to simplify both sides first. So let's say we have 3x plus 2 parentheses x minus 5 plus 6 on the left side, and then on the right side 4 minus parentheses 2x minus 1. First thing you want to do is do any distributing, like here, and so that would be 2x minus 10. And then over here also you would distribute on the right side as well. I wrote it as plus -1, but anyway, so 3x and 2x makes 5x. So now we're combining like terms. On the left side, you get 5x minus 4. After you distribute, you get this, and then you combine, you get -2x plus 5 on the right side. So then you have an equation that's much more simple, but this is an equation where you have variables on both sides. So that's why I talk about the next type is when you have variables on both sides. So here's, I'm continuing working on this equation. So now I notice I have 5x on one side and negative 2x on the right side. So to get rid of the negative 2x, I could just add positive 2x. And so that would cause the x's on the right side to disappear. So you just have 5. On the left side, you have 5x plus 2x is 7x. And so 7x minus 4 equals 5. And now it's a two-step equation. So just add 4 to both sides. You get 7x equals 9. Divide both sides by 7. And of course, the 7's cancel on the left side. And you end up with 9 over 7. X equals 9 over 7. So that's a multi-step equation. But if you have either a lot of distributing and combining like terms to do that first. If you end up with variables on both sides, make sure you get those variables together on the same side before you progress any further and move other terms to the other side. So an important distinction is that between an expression or an equation. Some students sometimes get those two terms confused and what you do in each case. And some students treat an expression like an equation or an equation like an expression. Like in this example, you have you have an equation. You definitely have an equal sign right there, right? So you can't combine things from opposite sides. Some students don't even see the equal sign, or they don't think it matters, and they try to combine the negative 2x and the 3x and get positive x and the 52 and the 12 and get 64. That's not correct. Do not do that. And then also the other way around, sometimes it's an expression like this. This is an expression, a negative 5x plus 15. There's no equal sign there, so you cannot solve it. It says evaluate, meaning just plug in what x is and find the value of that expression. Sometimes students say, oh, I got to solve that. And so they end up with an answer for x. But no, x was given to us as negative 2. Do not switch and think it's an equation, all right? All right, so that was just a quick review of things from FDLS 115. You definitely should be able to solve a linear equation of any type. All right? All right.